Today, let's dive into the fascinating and somewhat frustrating world of time travel. Specifically, why traveling to the past is a no-go. Alright, picture this. You've got a time travel portal that sends objects back 3 seconds. Cool, right? Now let's place this portal just above a trampoline. You turn on the portal and drop a charged battery into it. The battery falls, goes back 3 seconds, bounces off the trampoline, and lands above the portal again. 3 seconds later you drop another battery, but there's actually two now. The original and the time-traveled one. Before you know it, you've got an infinite number of batteries bouncing around. A business person might think, sweet, free batteries. But hold on. This endless loop means there's no way to stop the process. It's all happening in the same 3-second loop. And suddenly, we've got an infinite number of batteries in the universe, crushing everything in their path and causing a massive explosion. This brings us to a key point. The law of conservation of energy. This law keeps our universe from instantly turning into a giant fireball of energy. And it's one big reason why time travel to the past is impossible. Now you might be thinking, what if we remove the human element? Even if an acorn fell through a 3-second portal, we'd still get the same outcome, an explosion of infinite acorns. So the fact that our universe isn't a chaotic mess of infinite objects is solid evidence that time travel to the past just doesn't work. Sure, time travel makes for awesome movies and mind-bending theories from some respected physicists. But mainstream science says, nope, not happening. So what about time travel to the future? Well, good news. That's actually possible and has even been measured. According to relativity, time moves differently depending on how fast you're moving or how strong the gravitational field is around you. If you travel in a super-fast spaceship or hang out near a strong gravitational field, time will slow down for you compared to someone on Earth. You could experience an hour, while Earth experiences 2. But don't get too excited just yet. The effect is pretty weak. With our current technology, we can only travel milliseconds into the future. Still, it's a start, right? Let's switch gears and dive into the tantalizing idea of building a time machine. Imagine space-time as a 2-dimensional sheet of paper. If you fold the paper and punch a hole through it, you've created a shortcut from one side to the other. That's essentially what a wormhole could do in our 3-dimensional universe. It's like a tunnel connecting 2 distant points in space and time. But here's the catch. Creating and stabilizing a wormhole would require exotic matter with negative energy density. And as of now, this exotic matter is purely theoretical. Next, let's talk about the theory of relativity, specifically Einstein's general relativity. According to this theory, massive objects like stars and black holes can warp the fabric of space-time. If you could somehow harness this warping effect, you might be able to create a time machine. One proposed idea is the Tipler cylinder, a massive, rotating cylinder made of dense material. If you travel around this cylinder at near light speeds, you could theoretically move forward or backward in time. But building something as massive and dense as a Tipler cylinder is beyond our current technological capabilities. Then there's the concept of closed time-like curves. These are paths in space-time that loop back on themselves, theoretically allowing you to return to your starting point in time. However, creating such curves would again require conditions and materials we don't yet understand or possess. But what if we bring artificial intelligence into the equation? Can AI build a time machine? First, let's talk about the current advancements in AI technology. From machine learning to neural networks, AI has made remarkable strides in various fields, including medicine, robotics, and even space exploration. But can it help us crack the code of time travel? Theoretically, AI could assist in solving complex equations and simulations that are beyond human capabilities. Currently, our understanding of time travel is limited, and much of it is theoretical. Additionally, creating a time machine would require unprecedented levels of energy and materials, challenges that AI alone cannot solve. But now, let's shift our focus to a crucial question. Is anyone actually working on time travel? First, let's talk about theoretical physicist Kip Thorne, who has made significant contributions to our understanding of wormholes and the fabric of space-time. Thorne's work has inspired a new generation of scientists to explore the possibilities of time travel through the lens of general relativity. Next, we have the intriguing experiments being conducted in quantum mechanics. Researchers are investigating quantum entanglement and superposition, phenomena that could potentially be harnessed for time travel. Quantum physicists like David Deutsch are working on theories that could one day allow us to navigate the quantum realm and manipulate time. Let's not forget about the Large Hadron Collider at CERN. While its primary function is to study particle physics, Some scientists speculate that its high-energy collisions could provide insights into the nature of time and even create microscopic wormholes. Additionally, there are private organizations and think tanks dedicated to exploring the possibilities of time travel. These groups are often multidisciplinary, combining expertise in physics, engineering, and even computer science to tackle this monumental challenge. However, it's important to note that we are still in the early stages of this research. The theories are complex, the experiments are challenging, and the technological requirements are immense. But now, let's tackle an intriguing question that has puzzled scientists and philosophers alike. Is it possible to go back in time and change the past? The concept of causality, which dictates that cause precedes effect, is fundamental to our understanding of the universe. But what happens if we disrupt this linear sequence? One of the most famous examples is the grandfather paradox. If you travel back in time and prevent your grandfather from meeting your grandmother, would you cease to exist? And if you never existed, how could you have traveled back in time in the first place? Next, we'll explore the concept of alternate timelines and parallel universes. Some theories suggest that changing the past could create a branching timeline where a new reality splits off from the original one. This idea, rooted in the many worlds interpretation of quantum mechanics, proposes that every possible outcome of a quantum event actually occurs, resulting in a multiverse of parallel realities. Renowned experts in the field, such as physicist David Deutsch, have provided insights into these complex ideas. Deutsch's work on quantum theory suggests that the universe is a vast network of parallel worlds where every possible history and future already exist. In this framework, changing the past might not be about altering our timeline but rather accessing a different one. Would it be right to change the past, knowing that our actions could have unforeseen consequences? Unlike the theoretical physics and exotic matter we've discussed so far, mental time travel is something you can actually practice today. There are some techniques that can help you access and relive moments from your past. Visualization is a powerful tool where you create vivid mental images of past events. Close your eyes and imagine a significant moment in your life. Focus on the details, what you saw, heard, and felt. This technique can help you relive those experiences with remarkable clarity. Meditation is another effective method. By reaching a state of deep relaxation, you can access parts of your subconscious mind where memories are stored. Guided meditations specifically aimed at revisiting past experiences can be particularly helpful. These sessions often involve a narrator guiding you through a series of mental images and scenarios, making it easier to access your memories. Hypnosis is a more advanced technique that can also facilitate mental time travel. Under the guidance of a trained professional, hypnosis can help you unlock memories that are buried deep within your subconscious. This method is often used in therapeutic settings to help individuals confront and resolve past traumas. But how does mental time travel work from a psychological and neurological perspective? When we recall a memory, our brain reactivates the neural pathways that were formed during the original experience. Studies have shown that the same brain regions are involved in both remembering the past and imagining the future, highlighting the interconnectedness of memory and imagination. While the idea of traveling to the past often captures our imagination, the science of moving forward through time is equally intriguing and, surprisingly, more attainable. One of the foundational theories that support the possibility of future time travel is Albert Einstein's theory of relativity. According to this theory, time is not a constant. It can be stretched and compressed depending on the speed at which you are moving. This phenomenon is known as time dilation. Imagine you are on a spaceship traveling close to the speed of light. According to Einstein's equations, time for you would pass more slowly compared to someone on Earth. So while only a few years might pass for you on the spaceship, decades could pass on Earth. When you return, you would effectively have traveled into the future. Another method that has been proposed involves the use of wormholes, hypothetical tunnels through space-time that could connect distant points in time and space. If a stable wormhole could be created and manipulated, it might allow for instantaneous travel to different points in the future. However, the practical challenges of creating and stabilizing a wormhole are enormous and currently beyond our technological reach. There is also the concept of gravitational time dilation, which occurs near massive objects like black holes. The immense gravitational pull of a black hole can warp space-time to such an extent that time slows down significantly. If you were to orbit close to a black hole, without getting sucked in of course, time for you would pass much more slowly compared to someone far away from the black hole. This means you could experience a few minutes while years pass for others. Scientists are already conducting experiments to observe time dilation on a much smaller scale. From the early philosophical musings to modern scientific endeavors, we will explore how the concept of time travel has evolved over the centuries. Our journey begins in ancient Greece, where philosophers like Zeno and Parmenides pondered the nature of time. Zeno's paradoxes, especially the famous arrow paradox, questioned the divisibility of time and space, laying the groundwork for future debates. Fast forward to the 19th century, when H.G. Wells wrote The Time Machine, a seminal work that popularized the concept of time travel in literature. Wells's imaginative narrative sparked public interest and set the stage for scientific inquiry. In the early 20th century, Albert Einstein's theory of relativity revolutionized our understanding of time. His groundbreaking equations demonstrated that time is not a constant and can be affected by speed and gravity. This led to the concept of time dilation, a cornerstone in the science of time travel. The mid-20th century saw further advancements with Kurt Gödel's solutions to Einstein's equations, suggesting the possibility of closed, time-like curves. These curves theoretically allow for travel to the past, adding another layer to the complex tapestry of time travel theories. In the late 20th and early 21st centuries, experiments began to test these theories. Atomic clocks on high-speed jets and satellites confirmed time dilation, proving that time travel on a small scale is indeed possible. Scientists like Kip Thorne and Stephen Hawking explored the feasibility of wormholes and other exotic methods for time travel, though practical implementation remains elusive. Quantum mechanics and string theory offer new perspectives, hinting at the potential for time travel through quantum entanglement and multidimensional spaces. From the Grandfather paradox to the Bootstrap paradox and the predestination paradox, these conundrums challenge our understanding of causality and reality. Imagine you travel back in time and accidentally prevent your grandfather from meeting your grandmother. This would mean your parent, and by extension you, could never have been born. But if you were never born, how could you have traveled back in time in the first place? This paradox raises questions about the consistency of events and the nature of cause and effect. Some scientists propose solutions like the Novikov self-consistency principle, which suggests that any actions taken by a time traveler were always part of history, thus preventing paradoxes. Next we have the Bootstrap paradox, also known as the ontological paradox. This paradox occurs when an object or piece of information is sent back in time and becomes the very thing that causes it to exist in the first place. For example, imagine a scientist receives a blueprint for a time machine from their future self. They build the machine, travel back in time, and give the blueprint to their past self. The question then arises, where did the blueprint originally come from? This paradox challenges our understanding of the origin and linear progression of events. It suggests the possibility of self-created entities and information loops, which some theories in quantum mechanics and multiverse interpretations attempt to address. Lastly, the predestination paradox, also known as the causal loop. This paradox involves actions taken by a time traveler that lead to the very events they were trying to change or prevent. For instance, a person travels back in time to prevent a disaster but ends up causing it instead. Some interpretations of quantum mechanics, such as the many worlds hypothesis, propose that every action creates a new parallel timeline, thereby avoiding paradoxes.